Hey everyone, welcome. Today, we're diving into the heart of getting an engine started, the cranking system. At its core, we have the starter motor, a powerful electric motor designed to crank the engine until combustion takes over. The starter motor can draw a significant amount of power, often several hundred amperes or more, especially during that initial engine rotation. Upon completion of this segment, you will be able to perform the following: performing a starter current draw test and interpreting the readings against manufacturer specs. 2. Inspect the switches, connectors, and wires of starter control circuits for faults. 3. Understand the function of the starter, magnetic relay, and solenoid within the cranking system. A healthy electrical system and clean, tight connections are absolutely crucial. Loose or dirty connections create unwanted resistance, leading to excessive voltage drop. Think of it like trying to drink through a clogged straw. The effort is much higher, and the result is less efficient. Remember, the entire cranking system simply cannot operate properly with excessive resistance in any part of the circuit. So, how do we know if the starter motor itself is the problem? If you've checked your battery and all the connections seem good, but the engine still cranks slowly, the starter current draw test is your next step. This test allows us to see how much current the starter is pulling while it's trying to crank the engine. To perform this test, we first need to disable the fuel system to prevent the engine from actually starting. A common method is to simply pull the fuel pump relay. Always refer to the vehicle's service information for the correct procedure. Once the fuel system is disabled, have an assistant crank the engine. Using a high amperage clamp connected to your multimeter or a dedicated volt amp tester, measure the cranking amperage in the battery negative cable. Now, interpreting the readings is the most important key. You'll need to compare your measurement to the manufacturer's loaded test specifications. These specs will tell you the acceptable range for current draw. If the current draw is excessively high, but the voltage drop in the system is within the specified limits, it could be an indication of a defective starter motor internally, or even a mechanical issue within the engine itself that's preventing it from cranking freely. Remember, if the engine is hard to turn over due to a mechanical problem, the starter will have to work harder and draw more current. Never forget all the electronics are still attached to an internal combustion engine. Before condemning the starter itself, we need to thoroughly inspect the starter control circuit. This circuit involves the ignition switch, wiring, connectors, and often a magnetic relay. For the purpose of this segment, we'll refer to a starter control that is not attached to the starter as a relay. A starter control mounted on the starter will be referred to as a solenoid. Don't let different manufacturers' nomenclature distract you. Many modern starting systems use a magnetic relay located in the engine compartment to handle a high current flow to the starter. This provides a more consistent voltage supply to the starter motor. The relay essentially acts as an electrically controlled switch. Like any relay, it has a low current control side and a high current power side. The control side, when energized by the ignition switch, creates a magnetic field that pulls a contact disc closed on the power side. This allows the high current from the battery to flow to the starter or its solenoid. To diagnose a potential relay issue, start by checking for adequate voltage leading to the positive winding terminal of the relay. This wire is typically fed directly from the ignition switch when it's in the crank position. Using your voltmeter connected between this terminal and a good ground, crank the engine and compare the voltage reading to the manufacturer's specification. Next, test the voltage at the negative winding terminal of the relay to a good ground while cranking. Again, compare this to the specifications. Low voltage on either side of the control winding can prevent the relay from activating properly. We also need to check the voltage drop across the relay's main contacts. Please review previous modules in this section for a refresher on voltage drop testing. Connect your voltmeter across the main terminal fed by the battery and the main output terminal feeding the starter or solenoid. With the starter operating, if possible, or during a brief crank attempt, the voltage drop across these terminals should not exceed approximately 0.2 to 0.3 volts. A higher voltage drop suggests excessive resistance within the solenoid's internal contacts or connections. Finally, if the relay operates poorly or not at all, you can check the resistance of its windings using your digital multimeter, DMM. With the ignition switch off, and the relay de-energized. Connect the meter across the two winding terminals. Some external relays use the body ground rather than a terminal. A typical resistance should be around 0.8 ohms, but this can vary. An infinite or OL resistance reading indicates an open winding, meaning the relay is defective. It's often a good practice to check the resistance of a known good relay of the same type to get a baseline reading before condemning the unit. Many starter motors utilize a solenoid directly mounted to them. The solenoid serves two main purposes. It acts as an electromagnetic switch to engage the high current to the starter motor, and it also mechanically engages the starter pinion gear with the engine's ring gear. We need to perform a few key voltage checks on the solenoid while the starter is energized. First, test the voltage between the S terminal on the solenoid and a good ground. This is the small terminal that receives power from the relay or directly from the ignition switch in some systems. While cranking, the voltage here should typically be above 9.6 volts. If the voltage is lower than this, and you've confirmed the batteries are properly charged, the issue could be excessive resistance in the wiring of the control circuit leading to the solenoid, or a faulty magnetic relay if the system uses one. If you have good voltage at the S terminal, but the starter isn't engaging or drawing power, the solenoid itself might be the issue. Next, if your solenoid has a winding ground circuit, G connector, test the voltage between this connector and a good ground while cranking. This voltage should be very low, ideally not above 0.1 volt. A higher voltage drop here indicates a problem with the solenoid's internal ground circuit. Use a DMM or start with an analog meter on a higher voltage scale before reducing it for more sensitivity. Finally, test the voltage drop between the solenoid's B terminal. This is the large terminal connected to the battery or the output of the magnetic relay, and the terminal on top of the starter motor itself. During cranking, this voltage drop should be no more than 0.2 volts. A higher voltage drop suggests excessive resistance within the solenoid's internal contacts or connections. If you have proper voltage at the S terminal and a good solenoid ground, but you have a high voltage drop here, you likely need to replace the solenoid, or in some cases, repair its internal contact disc. Before replacing any components, always remember to visually inspect all switches, connectors, and wires in the starter control circuit. Look for signs of corrosion, damage, loose connections, or frayed wires. Clean and tighten any suspect connections and retest as necessary. A simple visual inspection can often reveal the root cause of the problem. So, to recap, diagnosing cranking system issues involves understanding the high current draw of the starter, performing a starter current draw test and interpreting the readings against manufacturer specs, and meticulously inspecting the control circuit, including the magnetic relay and solenoid, sometimes through voltage and sometimes resistance checks. By following these procedures and paying close attention to detail, you'll be well on your way to accurately diagnosing and resolving cranking system problems. Thanks for watching and your continued commitment to ASE testing.